Welcome to probability videos 10-2 and 10-3, probability of dice and free throws. All right, so there's a couple examples. I'll start with example 2. So you roll a single die 8 times. Find the probability that at least one of those rolls is a 6. Very important vocabulary, at least one. And again from before, if you've got at least one, I could do the complement that's the same as 1 minus the probability of none. So let me just draw you that. So here's my total probability. Over here I've got at least one. In here I've got none. Again, the probability total is 1. So if I ever want to find the probability of at least one thing, I can just take 1 minus the probability of it not happening. Okay, so that's what I did here. So I've got 1 minus the probability of no 6s. Okay, so let's find the probability of rolling no 6s all 8 times. Well, the probability of rolling a not 6, so the probability of a not 6 on one throw equals 5 over 6, because there's 5 not 6s out of a total of 6. So for the first roll, not getting a 6, 5 out of 6. The second roll, 5 out of 6, etc., etc., etc. An easier way to represent that would have been just 1 minus 5/6 raised to the 8th power. So that equals 1 minus 5/6 raised to the 8th power. And this time I'll give an approximation. The fraction would be very ugly, about 0.767. So that would be about a 76.7% chance of rolling a die 8 times and having at least one of them being a 6. Okay, the example 3 involves basketball with free throw percentages. So we've got 2 different basketball players to consider. Steve Nash, who had one of the best free throw shooting percentages in all the NBA with 90.4%. And then Shaquille O'Neal, one of the lower free throw shooters, 42.2%. So we'll do the problem here, and then this one will be really quick. All right, so Stephen Nash had a free throw shooting percentage of 90.4%. That means every time he went to the line, there was about a 90.4% chance he would make his free throw. So let's suppose he attempted 10 free throws in a game. What's the probability he would miss at least one? Again, probability of missing at least one is the same as 1 minus the probability of missing none. Either it's going to rain or it's not going to rain. Either you're going to have at least one of something or none of something. And hopefully you're okay with missing none is really the same as making all. So it's now 1 minus the probability of making all 10 free throws. So now I'm just going to borrow that template right there. And it's going to be 1 minus making all 0.904 raised to the 10th. Just like that template there. Okay, so if you work that out, again, we'll use a decimal. You get about 0.6355. The problem said to make it be a percentage, so about 63.55%. Okay, now let's do the same problem with Shaquille O'Neal. So the only thing that's really going to change is that number right there. Instead of being 0.904, it'll be 0.422. So it'll be 1 minus 0.422 raised to the 10th power. And we would get about 0.9998, or approximately 99.98%. So you can clearly see it's almost inevitable that Shaquille O'Neal will miss at least one free throw. That's almost guaranteed. For Steve Nash, not quite as much. So there you have it, how to use probability, really with complements, to find the probability of dice and free throws.